So now that I've started recording, welcome to the AgroIntelli online training sessions. This first session, as I just said, is the refresher into the planning website and all the features that are part of the website through 2023. So I'll start off with a brief introduction, and then I'll dive straight onto the website and go through how we go about uploading and modifying fields. Then I'll talk about some of the basic operations that we have and talk about some of the meaning behind the operations and what they actually are. Then I'll do show you how we create rows and create areas, both of which were kind of new features in this past season. And then I'll talk about some of the advanced features. And following all this, we'll have a question and answer session where anyone's welcome to come with any planning related questions and answers. Well, questions, hopefully I'll come with the answers. Starting with the introduction myself, my name's Gareth Edwards. I've been part of AgroIntelli from the very beginning. I've been in charge of developing the website and the planning tool, and the whole digital platform, cloud platform. So everything basically between the user and the robot kind of falls into my domain. So uploading and modifying fields. Let's dive straight into the website. So here's the website, as we all know. I'm here logged in as my own user, and I'm going to upload a field. So to upload a field, of course, we click on the green button. We can put it on a farm. I'm just using my default farm here, but you can add another one. And I'm going to upload a field that I recorded the GPS for. If I can just get to that. So here you can see that the field has been recorded at our training facility here in Aarhus in Denmark. But as you can see, the border of the field is quite messy. Ideally, we're looking for nice straight lines across the edge of the fields. But as we all know, when we record, we get these kind of wibbly lines, but that actually follow the edge of the field, and that's okay that they're wibbly. Sometimes, though, that can cause a few problems. So a recent feature that we added is the simplify field feature. As you can see, all these dots represent a different dot along the boundary. So there's a lot of dots. It's a complicated field. So I can use the simplify tool here. When I simplify, it asks me to put in a distance here. I have an explanation of that. So when we're simplifying fields, we're putting in the distance that we're allowed to move dots into the field to make a nice straight line. So if we remove this dot, we'd get a nice straight line between these two dots. And as long as that distance there is less than the distance we've said, then we should be able to simplify it. So going back to the field, here, if I put in 0.5 meters, I can then preview the results. And as you can see, if I zoom in here, there are a number of points that have been taken out to make this field simpler. So if I click yes, then you can see this field is a lot simpler than it was before. And that's good, especially if we're creating plans with headlands. We want nice, simple fields. After this has been done, of course, you can always go in and use your rubber to remove some more points. You can take out some more points along the headlands here to make it more simple. What you can't do is move outside of the field. So if I remove this point, it's going to take the line outside of the field, and then I get an error. We assume that the field that you've uploaded is safe. Therefore, if you cross outside of that field, then you're crossing into unsafe area. So we won't let you do that. So you can only actually make the field smaller. thereby kind of remaining inside the area that you've already said was safe. If that is okay, then we can move forward. At this point as well, we can also add obstacles if we forgot to do that when we were recording. One important thing to note is that the images you see here are from Google, and they're 99 times out of 100, the images are wrong. Where you see an obstacle on the image might not be where it is in real life, so you can't really trust it. Or if you do trust it, you need to put a bigger obstacle than what's shown on the thing, on the image. The best way, of course, to do it is to record it in real life. However, if we have to add an obstacle, we can add it in such as this. A bit more of a rounded shape. If I flip back to my presentation here, quite often when people are creating obstacles, they might have a GPS position in the center and then create the obstacle around it. And quite often they create the obstacles just as a simple triangle. This is fine, but it's not good for the planner. Basically, the robot is going to want to drive around the obstacle, hopefully. But so if you put sharp corners like this, it's going to make the robot take much bigger corners around it. It's better if we create a more organic shape with more points on it. And if we know that we're driving, say, in this direction, if we can make kind of the parallel lines of the obstacle be parallel as well, then it's going to be able to drive closer to that obstacle. But the best option, of course, is to try and create it as a circle. If you've got the center GPS, then you can try and create a circle around it. So here I've created this obstacle. But let's delete that because there isn't actually one in the field. So now I can save that field and then start using it. So here's the field that we've just uploaded. Now I'm not actually going to go into discussing how we create implements here because a little spoiler for next week, we have a whole new way of creating implements. So I'm going to save that for the next session as it'll be completely different for next time. It's not completely different, but there's a lot more features that we've added for creating implements now, so you get a lot more flexibility in how you want the implements to be created. So if I go into operations, so here, as you know, we've got a number of different operation types. We've got headlands, turning areas, transit rows, and a bed system. Let's start first with headlands. So what are headlands? When we create a plan with headlands, it creates passes that go all the way around the field. These can then be worked by the robot and used for when we're driving in between the rows. We also have this distance here, which we say is a safety, we call the safety distance. Now, a lot of people are wondering how they can eliminate this distance, but this distance is needed because of the width of the robot and the width of the implement. So as a default, this distance is set to the minimum. You can actually increase it if you want to, but this is the minimum distance that the robot needs to be able to drive and turn onto the outer headland. Yeah, so unfortunately at the moment that is needed. The rest you can, when you're created a headland plan like this, you can select if you want to drive the headlands or not, work the headlands or not, sorry, by turning them on and off. We also then have a number of methods for how we drive the headlands. We have fixed corner radius, we have varying, and zero turns. So if I go to my little icons here, This is a fixed corner radius, which means we drive the same radius going around all of the corners. We have and as you know, when you're driving a radius like this, there is a small amount of mist area on the inside and the outside of the corners. So that will be a small amount on every single row. With the varying corner radius method, we increase the size of the radius as we're going out into normal turns like this. Therefore, there's no mist field as we're going around these corners, but it's all pushed to the outside here. The actual area that we're missing on these two different styles is exactly the same. It's just that on this method, it's all pushed to the outside of the field, which might be desired because it's normally the outside part of the field that's the less profitable part of the field. It should be noted as well that if you've got corners like this, convex corners where it's coming into the field, if you use the varying corner method, you're going to get this area against your field area. So if the rows were going here, you're going to get a missed area here. So often, if you've got a normal square field, it's fine doing very radius corners. But if you've got a field with like an L or a big inward angle, I wouldn't recommend doing variable corner radius method. We've also as well got the zero corners, which means we do a zero turn in the corner. As you know, the robot then it drives into the corner and it does a turn around its center of the back axle, so it can get much further into the corners. There is of course then the issue of a lot of overlap on the inside of the corners, but that if this is okay, doing the zero corner method misses less area than the other two methods, but it also increases the area of overlap. So it's up to you which you need for your operation. Operations that are good to use headlands for are operations where you're doing establishing the field, if you're doing tillage work, or if you're doing a broad crop where you want to use the whole field, then this method is going to give you the best coverage. So next we have turning areas. Now turning areas are when we have where we're mostly interested in working the center part of the field and aren't too concerned about working the edges of the field. When we do turning areas, we don't work the edges and we just work the rows that are there. If I just pick an A-B line here. So to be able to establish your turning areas, you need to have an A-B line. I'm going to do a follow edge A-B line, and I'll just take the top edge here. Now, ideally, I want to take this whole edge because I want to drive parallel to this whole edge. So once I've clicked near the edge, and then I get these little plus signs, meaning I can increase this all the way into the corners, and I can increase this way too. I could, if I wanted to, follow this line all the way around this edge as well, and then I would work parallel to that all the way down the field as well. But I'm happy just doing it next to this top edge. So if I then, once I've got my A-B line selected, I can select my turning areas. So when we do this method, it automatically suggests which sides of the fields should be used for turning areas. This isn't a great field for turning areas, but I actually want these to be part of the main field. I don't want them to be turning area. So if I click on those, they turn to being free, and it's just these blue areas which are the turning areas. So if we look at that, then I have my turning areas here, and I have my rows going across the field. I can't put any rows in this part of the field because although they'd be able to start in this turning area, they wouldn't be able to finish in this turning area without hitting the edge of the field. I could have, of course, chose my AB line as the bottom part of the field here, but then I'd get a similar instance here where I'd miss a small area there. Yeah, so when you're selecting turning areas, you select the width and you select the border to transit distance. This is another value that has sometimes caused confusion when people are making plans. So what is the border to transit distance? Well, this is the distance between the edge of the field and this dotted line, which the robot will use to turn around. So the robot, when it's doing its rows, it'll work the row and then finish working, drive to this, ideally drive to this this line, drive along, and then drive into the next row. However, we've put this row and this line here a minimal distance away from the edge of the field. So if you're trying to make your turning areas as small as possible, then it's very good because it's going to give you the best chance of being able to create a plan. However, if you've got quite large turning areas, say over 8-9 meters, then there's really no need to put this border to transit so close to the edge of the field because there's plenty of room here to turn around. So often when I'm doing 12-meter headlands, I'll raise that to 5 meters. We can just see what that does. So now I've raised that to 5 meters. You can see this line is a lot further away from the edge of the field. This is going to give us more room to turn around. Often when we're doing the minimum distance here, we can't actually make it onto that line using a zero turn. We have to use a normal turn. When you're doing a zero turn, because you get to a point and then pivot rather than doing a nice smooth turn, you actually need more room to turn around. So often with plans, people will see these strange types of turns where it's doing a smooth turn onto the line and then doing a zero turn and coming down. If it's doing that, that tends to be because you could increase your border to transit distance and create a better plan. Yeah, so doing it this way, we can create, if there's plenty of room, you should use it so that there's more room for the robot to turn around. Next, we have transit rows. So transit rows are very similar to turning areas. It's just you can put them wherever you want them. So with turning areas, they are a distance away from the edge of the field. Transit rows, you can put them anywhere in the field. If I were, I could put a transit row here, for instance, and here. You can also design your transit rows in another software and then upload them here using shapefiles. So using transit rows like this, you get more control over where the robot's going to be driving when it's going in between rows. And I quite often get the question, how do I do, say, 6-meter headlands at this side of the field and 12-meter at this side? Well, the way to do that would be using transit rows. So as you can see, they don't have to be the same distance. Again, if you're clicking on the map like this, then you can't trust the image behind. What I often do is if I want to create a set of transit rows here, I can, if I do an AB line parallel to this edge, And then I do another AB line parallel to the other edge of the field. Then I can use my transit road generator, and I can generate some transit roads from those AB lines. So if I take my west AB line, and say I want a road that's 6 meters in from the edge of the field, and then I want one on my east side, and I want it, say, 9 meters in, and this is the center. So a 6 meter is basically doing a 12-meter headland. So actually, if I make this, yeah, if I make it 9. And then I go, okay. And then I've got a set of transit rows here at different distances from each side of the field. Again, when you're doing transit rows, you can set the width of the field. And this is taking the line that you've uploaded as the center of the transit row and then creating kind of the distance either side of that, which then creates the rows. One thing that's very important with transit rows is starting points. I haven't talked about starting points yet. What is the starting point? So the starting point is the point in the field that you think you'll start the robot at. Fields being what they are, they generally have a gate into them and a gate out of them, and you tend to put the robot near the start gate. So when we're creating plans, it's good to know whereabout you'll be starting the robot. However, of course, when you put the robot in the field, you don't have to put it in exactly that right place. You put it somewhere and then it works out where it needs to go once you've started it. But if it's doing an optimization, for instance, doing the row by row or the optimized methods, then it's going to presume that you're going to be starting near the start point. However, when you're doing so normally with headlands and turning areas, with headlands you can put the gate anywhere around the field because the headlands go all around the field. When you're doing turning areas, you want to make sure the gates are in a turning area. Both the start gates and end gates are in a turning area. When you're doing transit rows, then these don't actually touch the edge of the field anymore. So whereas the gates are touching the edge of the field, there's going to be a distance between the gate and the area it can use to drive to the first row. So I generally recommend that if you're going to use transit rows, then you should use, you just pick any starting gate, but then go into advanced options and make sure you choose an entry and an exit. Just so that you don't have to use the gates, because if the gate is far away from the transit row, then it's going to have problems creating the plan. So it's a good idea that if you're going to use transit rows, that you specify your start and end row entry and row exit points. So here in this plan, I've specified that I want them to start here and end here. So if I was doing a row by row, of course, it would go across the field. If I'm doing optimized, it can go how it needs to make the shortest route, but still start at this end of the row and end at this end of the row. Let's just pop back to the presentation to make sure we're on track. Okay, so I've talked about all the operation types now, getting on to beds. So what is the difference between AB lines fixed rows and beds. AB lines are just a line. Whenever we create the rows or use them to generate anything else, it's the center line of what we'll be driving, and then we expand them across the field, making sure that only rows that start and end in an area are included. That's why there's no rows generated up here or below here, because it only creates rows where it can start in an area and end in an area. It's similar for fixed rows. So fixed rows are also generated such that they have to be, if I pick this AB line, and I generate my rows. And I save these as fixed rows. And then I save them also as beds. And then I go back. So now I have these things. So if I've got fixed rows, when I generate a plan with fixed rows, the planner, it doesn't have to start and end at the start and end of the fixed row. The fixed row has to start and end in an area where it can turn around, so they get extended. If the fixed rows were only in the middle part of the field here, they'd be extended to the edge of the field, to the edge of the work areas. So in that way, they're very similar to AB lines. You still need somewhere to turn around. With beds, however, a bed is defined as a line. So here, if you upload something as a bed, then the robot will always work to the edge of the bed, no matter where your transit rows or turning areas might be. So you can actually create, when you're doing it as a bed system, you can choose beds without any areas here. So here it'll work the whole row and then turn around and work the next row. You're welcome to do it with transit rows if you want to, which helps the robot turn around and kind of helps you control where the robot will turn around, but it's not necessary. In fact, if you have beds that don't touch the turning areas or the transit rows, then it will just drive straight until it can just drive straight until it gets into one of them. If we yeah, so the point of the bed system is if you want to control exactly where the work starts and ends. And then you can have the added control of the transit rows if you really want to control where it turns around. Another thing to be very aware of with fixed rows and beds, when you upload fixed rows, if you have obstacles in the field, then the rows will be bent, then the fixed rows will be bent around the obstacles. If you upload beds, then it won't be. If you've uploaded a bed, we presume that you've recorded that bed and you know where that bed is. That's why you want to specify it as a bed, because you know that this is my exact bed. I know the start and the end, and I want that to be worked. But if you've got an obstacle there, it doesn't bend beds around obstacles. So you have to know that and have recorded it around the obstacle. So let's get into a few of the advanced options here. I'm going to go back to creating a turning area plan, just so I've got something to work with. Okay, so we've got these tick boxes here as well. So 0 point turn. That's when that's ticked, that allows the robot to do a 0 turn at the end of the rows here, if possible. As I said before, a 0 point turn takes slightly more room to do. It needs more room to the edge of the field to be able to do a 0 turn, so it can't always do one. But if it's possible, it will do one. The work curved paths, that's mainly used for when you're doing headlands. If you've got headlands that go around the field and they've got corners on them, it's whether or not you want to carry on working while going around that corner. It's based on your implement, basically. Some implements will be able to handle that shear you get as you're driving around a corner. Some implements won't. So if you've got an implement that only wants to be working when you're in a straight line, you should turn that off. We do allow a small amount of turn. For instance, these rows aren't straight. They're slightly crooked because they're following this edge, which is slightly crooked, but it would probably still work that whole row, even if you've got work curved off. Work overlap. Now this is if you want to work the overlap between rows and the turning area. So here we've got work overlap is ticked. So the robotic would drive all the way and work to the end here. If you don't have that ticked, then it will only work where it can work the full row. So it would get to here and then stop working. So it's whether or not you want to kind of overlap or not overlap. Some things, such as seeding, of course, you probably want to work the overlap so you get your field completely seeded. But if you've got crops here, and if you're doing a headland and you've got crops and you're doing a mechanical weeding, perhaps you want to not work the overlap. So the mechanical weeder stops here and doesn't weed this last part, because you might have crops going in the other direction here, and it might destroy those crops rather than which wouldn't be what you want. We then have the different driving patterns. So at the moment we just have 3 here. Although, in a slight spoiler for the next session, we're introducing 2 more here before the 2024 season. So basically, the standard method is the row by row, where the robot will try and work each row as it's going across the field. Again, if you're going to do a row by row method, I highly recommend that you choose the starting row. For instance, here we've got the gate in the middle of the field. So doing a row by row, it's going to start at the closest row, which will probably be this one, and then it will go to the next closest row, which will be this one. So even though you've chosen the row by row, it'll start here, probably work this part of the field, and then come back and work the rest of the field. Whereas if you use your advanced options and choose the entry point to this part of the field, then you know for sure that it's going to start at this edge and then work its way down. You could put the end point down here as well, just to be sure. I'll come back to that one. So then the other methods, optimized. The optimized method takes as a starting point the row by row method, and then applies some algorithms to it to see if it can make the operation be more optimal. So if it can be done quicker. So you're pretty much guaranteed that the optimized path will be quicker than doing it row by row. However, you don't know exactly the order of the rows. I mean, you do once you've created the plan, but you don't know ahead of time what the order of the rows are going to be. And when you're working it in the field, if you were planning on stopping it halfway, it might then be difficult to restart the operation because you don't know exactly maybe which rows have been worked and which rows haven't. Again, I think this is a personal preference, which methods you choose. I tend always to choose the optimized method. I invented it, so I trust it. But this one will always get your fields worked in the shortest amount of time. Finally, we have the grouped method, which is a mixture kind of between these two. So when you choose the group method, you have to say the group size, and this is basically how many rows it's going to group together. So starting at one side of the field, it groups together. Here I've selected 6 rows, so I'll group together the first 6 rows, and then try and do an optimized pattern over those 6, and then the next 6 rows, and then an optimized pattern over those 6. So you're still, by doing the group method, you're kind of limiting the optimization, so it won't be as optimal as the optimized, but it's likely to be quicker, still quicker than the row by row method. But you get the added advantage that it will still just work in a small group of rows, and then a small group of rows, and then a small group of rows. So you'll still kind of get that one side of the field to the other side of the field momentum. It's just in a more optimized way. So it's kind of in between the row by row and the optimized. So then if we go into the advanced options. So one of the as always, we can select which rows we want to work and which ones we don't. We've added a new feature now where we're able to specify the direction on the rows. So if we choose enforce direction, then we can, for each row of the field, we can specify which direction we can drive it in. In certain crop setups, this can be very useful. For instance, I know we've had customers who have been working with, say, a seeder that seeds 3 rows at a time, and then they want to go behind and weed, but you want to weed in the same direction that you seeded. Therefore, for the first 3 rows, you want to work one way, the next 3 rows, you want to work the other way. We can do that here. So here you can see this little symbol, which means we can drive in either direction. If we click on it once, it means we can only drive one way. Click on the other, and it'll only drive the other way. Or again, we go back to both. So say we can work the first 3 rows only in that direction, the next 3 rows only in that direction, and so on. This can be very advantageous if you want to control the route in your field more. I would recommend that if you are going to do something where you are controlling the direction on rows, then you use the optimized driving pattern or the group. You can choose row by row, obviously, but it's going to have a much harder time doing it. So if you're saying that you want to drive this way down this row, and then the next closest row is this one, but you can only drive in this direction, then it's probably going to loop back through another row that it can go down to get to here to go back down this row. So you're going to incur a lot of driving and a lot of kind of driving along rows, while not working them. So you can do it, but if I would recommend, if you're going to specify the direction on the rows, that you use an optimized pattern. Yeah, as well as clicking on the dots here, you can also click on them here in the menu. As you can see, these have all got a direction specified. It's very easy to do that. Yes, I wanted to talk a little bit more about entries and exits as well. Throughout this time, I've been just putting the entry and exit kind of on the first and end rows, but it is good to know how many rows you have. So I can see here that's my first row, and then I've got my 31st row. So actually I do have an odd number. So in that way, they're going to be, this first row is going to be driven in this direction, and the last is also going to be driven in this direction. Had I had an even number of rows, say if I don't want to work this one, don't want to work this one, then it's going to be hard to end at this end of the row. Therefore, I should check how many rows I've got so that I can put the exit at the right end of the row. Again, the planner can do it. It's just going to incur, if I had the exit here, the planner can do it. It will just incur extra driving across the field so it can get to the right place that I've specified. Of course, with specifying the direction of the row as well, if I click here, I can only specify that it drives that direction. I can't specify that it drives in the other direction because it's only either free to drive in both or in that direction. If I was specifying that it could only drive in the opposite direction, of course, I wouldn't be able to get to the finish line. Then we have lead in and lead out. These are new things that are added, and these are basically the lead in is how long the robot has to drive in a straight line before it starts to work. So these are set to the minimums as well. So a specification of the robot is it has to be driving in 2 meters for 2 meters straight before it gets into the road, just so it can get nice and straight, so you can get nice straight rows when you're driving along it. You can of course increase this, but you can't decrease it below 2. And the same with the lead out. And finally, we have work areas. So previously we've only had work areas, but now we've added a few different types of area. So if I want to add them here, I can create work areas either in another program and upload them, or I can create them by clicking on the map. Again, it's probably better to record them and upload them than it is, but I'll demonstrate it using clicking on the map. So here, if I say I only wanted to work a small part of the field, say I know I've got an area down here that I want to work, and an area up here that I want to work. Then I can create that. So when we're creating work areas now, we can choose 3 different types of area. So we get the work area. What's a work area? So when we've selected areas like this, the robot will create a plan where it drives and only works when it's driving over these areas. So actually, it will ignore these rows that don't have any work on them, and only create a plan where it's going through this area. And it will drive the whole row, and then drop the implement as it's going along the area, and then pick it up again after it's done, and then drive the whole row. It won't turn in between rows. It'll always still get to the end of the row before doing any kind of traversing. If we had it as a non-work area, then it's the opposite. So this area is the only area of the field where it won't work. So it'll work all the way along here, get to here, pick up the implement, and then drive across there, and then put the implement down again, and then drive again. If you had a row that was only inside the work area, the non-work area, then that wouldn't be included in the plan, obviously. So if this non-work area, say, covered that whole side of the field, then it wouldn't work any of that side of the field. If you create a plan that has a work area and a non-work area, then it kind of just ignores the non-work area, because by specifying a work area, the whole rest of the field is a non-work area anyway, so it doesn't make sense that you would have a work area and a non-work area kind of in the same. The third type is an avoid work area. So here, say if I knew this area was likely to get wet, or if I'd gone out to my field this morning and I can see that there's a big pool here. Well, then perhaps I don't want to make it a non-work area where we pick up the implement but still drive through it. If the robot can't drive through it, then I would want to make it an avoid area. So by doing that, it makes it similar to an obstacle, where I'm going to drive along and then drive around it, stop working, drive around it, and then start working again. So in that way, yeah, an avoid area is very similar to an obstacle. So then I often get the question, why shouldn't I create all my obstacles as avoid areas? And that's a very good question. You are, of course, welcome to create all your obstacles in your fields as non-work areas. However, then you've always got to remember to turn them on. If you forget, then the robot could drive into something and damage either the obstacle or the robot, neither of which we want. So I would say be very careful. Don't use avoid areas to create obstacles in fields. Use the obstacle creator to create obstacles in fields, and use the avoid area here for if it's an obstacle that isn't always there. So if you do have an area that's liable for flooding, or I don't know, if you're storing something on the field that you store for part of the season and not the rest, then yeah, you're welcome to use an avoid area. But I'd be very careful about what you use it for, because when you're creating a lot of plans, you can easily forget things, turn them on. Yeah, so if I make that use a work area, and then here under my work areas, I've got my 2 areas that I can turn back on. And although we make them default be work areas, we could, if you've done that by mistake, you can always change it to be in, say, this one to be an avoid area and this one to be a work area. Again, that wouldn't have any effect, because when it creates the plan, it's only going to create plans that go through the work area. So even though you've got an avoid area here, you're still only going to get a plan for this part of the field. If you had it as a don't work area and a work area up here, again, you're only going to get a plan for this part of the field. If we don't have that one selected, so we've only got this one as a don't work area, then we're going to get a plan for the whole field that stops working in this area. As you know, then when we've created our plan, we get an email when that's created, and we get our little bell icon here, which will turn to on. One more thing that I wanted to show, if we go into the view plans, and if I choose some plans that I already have, a new feature that we added in the last year, which some people might not be aware of, is that we can edit plans. So if we get to this one, this was the one that we just created. And here you see I had a non-work area. So it's created a plan with that doesn't work in this area, but works the rest of the field. So if I realized, oh, actually, no, I meant that as a work area, not a non-work area, then we can go into edit plan here. And then if I press edit plan again, then what it's going to do is it reloads the planner with all the settings that I made for that plan. So it's really easy then to create the plan again. So if I just so here we've gone back to where we were before. And if I said, oh, I wanted that to be a work area, not a non-work area, then I can just change that back to a work area and then plan that. So just wait a few minutes for that to create. Oh, and one last thing that I wanted to also show is we have a feature for sharing fields. With my fields, I can now share them with other users. So that I can create fields and plans for someone, and then share it with another user, so that they would also be able to create plans for that field, and they're all then stored under the same field. So it's not a duplicate; it's having access to the same field. So say I wanted to share this field with a user, I can click share. As you can see, there is already a number of users that I've shared this with, but I have to search by email for a user. So I need to know their exact email if I want to share the field to them, and then it shares them, and click that, then that field is shared with them. I can also go ahead and unshare fields, so I can remove users from them. When you have a field that's shared with you, you obviously then can't share it with someone else, but you can view it, and you can view all the plans that have been created for the field, and you can view all the operations that were driven on the field as well. So it's a great way to be able to collaborate. So now that my original plan was finished, so here we've just created the plan as a work area, and now it's created the plan where it only works when it's driving across that area. So I think that pretty much sums up everything that I wanted to cover here in this first session. I think we should take a short break, and then continue at 2 o'clock. So if we take a quick 5-minute break, just to refuel, and then I'll be able to go ahead and answer any questions that anyone has about the planner, or about any specific cases that they were trying to create plans for. If not, I've got a small demo I could run through as well about how to create transit rows and different types of field setups. Okay, so if we just pause then until 2 o'clock. Thank you.